Handasa Podcast.
Assalamu alaikum. Welcome in a new episode of Handasa Podcast. In this episode, myself, Bahri Sheikh, and my colleague Omar Al-Lafi will talk about RBI. Welcome with us Mr. Saqib Jalal, who is one of the most experienced engineers in the field of the RBI, more than 15 years in multinational companies in the Gulf and in different countries, and more than 10 years working in the RBI.
I think, Bahar, when it comes to RBI, when you see RBI or risk-based inspection, what's the first name that comes to your mind?
Exactly.
That's our go-to go.
There is something about RBI. We need Mr.
Yeah.
Yes.
He's our go-to-go guy. So nice to have you here with us today, Mr. Saqib, and we'll be covering RBI today. I think this is a new era of inspection. Previously, we used to do the time-based inspection and condition-based inspection according to the inspection codes in API 570, 510, and 653. And today we are going to speak about the importance of RBI, why is it important, and how it is being implemented.
Okay. Thank you, Omar, and thank you for the detail inviting me on this very good session there. So inshallah today we'll discuss in the detail as the agenda has been mentioned by Omar there, and we'll be discussing the detail about all the foundations and how it moves and what is the benefits. So during that discussion we'll see that one.
Actually, we have set some points which we believe it will cover to a good extent the RBI, but I believe from the discussion today, if we just give you the chance to explain, we'll have more and more than what we're expecting. But just as a start point, let's say what and why. What is RBI and why RBI actually is matter?
Yeah, so this is a very good question which Bahar, most of the time the people, it came into my mind that why I have to do the RBI for this one. So let me give a back of the history of the process industries there. Back in the late 20th century, about 1850, there was a very big process safety incident occurred in one of India, I believe. So this is one of the pioneer industry in the petrochemical, and they are very good in their standards and this. But this incident results almost 200 plus fatalities. So they did a detailed investigation on this incident, and they come up with a model there. They identify the gaps where they should have to focus it, and what are the key pillars which they need to focus in their future to avoid such situations. So they have made one model which is named as a process safety model, and it is famous in the industry named as a DuPont process safety model. Okay. So one of the pillar for that model is they identify the asset integrity portion, which they are lagging. There is a lot of gaps in that area. So they develop that model in that process safety, the asset integrity, and from there they develop the different phases of the inspection fast there. So if we'll continue in that same symmetry, they have identified one of the pillar of that model is the inspection. They have seen these things that earlier inspection of the equipments are run to fail. So this is the concept of the maintaining our assets. Run to fail means that equipment let it to be run, produce until it failed to do its function. Later they come up with the next phase, which is they say, okay, let us do the inspection in the planned intervals. Based on that, the foundation of API 510, 653 and 570 taken board, and they have defined some time intervals for the specific equipments and the type of inspections like external and internal, fixed interval 5 and 10s. With the passage of the time, later also they come to know that this fixed intervals we can optimize further. If my one equipment after 5 years there is no issue, and same another equipment there is an issue before 5, so why I have to inspect it? So they bring the concept of the condition based inspection, in which what they used to do based on their deterioration rate and their corrosion rate, they fix their intervals, which is they set good practices. They define some intervals in the inspection standards and code, which is 510 and 570 and 653. And the last data which is now going on is which is named as RBI. They come up with their concept. Okay, whatever my equipments, if we have an issue there, so we are ready to accept its consequences. So that concept has been bring that the risk-based inspection there. So that from where this RBI foundation and pillar has been taken off that.
Okay, so if I can put a little bit a title or a conclusion to that, it is something driven by maintaining the integrity of the equipment while allocating the optimum resources and from economical perspective.
Yes, exactly.
But started mainly from safety perspective.
Safety.
So the inspection codes and practices will determine the inspection interval based on like half remaining life, but it doesn't consider, or before consideration, there is a maximum interval, like regardless of the half remaining life, it cannot exceed 10 years
Exactly.
for example. Am I right?
Yes.
So with RBI, that's an important thing. We can exceed this inspection interval, or and also it can consider like the operational damage and aging factor. So it can accurately determine the inspection interval considering other factors from process, from operation, and from aging as well.
So this is the things there that what we, as I mentioned, the timeline for concept there, that moving from condition-based concept to the risk-based concept is one of the the benefit or our expectation from RBI is to focus our resources in a right asset. There is a very famous proverb which is in the risk is very famous, that within your facility, any process industry, 80% of the risk belongs to 25% of your assets. If I have 100 plus assets there, from that only these 25% of assets are the most contributor in our business, in our process safety and in asset integrity there. So we have to identify those assets and we have to put our maximum efforts means maintenance and inspection resources on those assets. For rest of the 81 will define some risk, and with the passage of time we'll re-evaluate its risk there. So this was the one of the our application, you can say it, that, and the advantage of the RBI to identify those equipments there and focus our resources. As per API 581, this is named as inspection plan, that right resources to be used on right asset at right time. This is the scripts of the inspection plan, which will elaborate to us. And RBI inspection plan is one of the outcome of the RBI there. So basically in the RBI we have three things. We are able to get the inspection plan, risk level, and when to inspect. So these are the three outcome of the RBI which we are getting.
So mentioning the risk here, we're talking about relative risk, not absolute risk.
Yeah, exactly. This is the thing there. That sometimes this is one of the RBI our expectation, that RBI will always identify the relative risk there, not the absolute risk there. Absolute risk, not the relative. What this risk basically is there, like I have defined the risk for my asset based on certain condition and requirement, and this is risk based on this operating condition. But if there is some nearby incident occurred, it will impact the envelope and the risk of that equipment. It will not be a tool can be used to identify the consequence or risk of this equipment. So this is the absolute risk which we are talking about. RBI cannot mitigate such things there. This will be, we'll discuss, I explain you how the basically, we'll discuss about the workflow, how the RBI workflow is moving it.
Yes.
Before moving to that one, the RBI workflow, it is one famous, the good thing we have to formulate a team. RBI, first of all, is not a single man job. This is the teamwork in which the couple of SMEs and our expert feedbacks is required. So generally or most probably in that workshops, there is some process engineers specifically for that area where we are going to do the RBI. Then we have operation, maintenance, inspection, corrosion engineer, process safety engineer. So all of these people will provide certain inputs to perform the RBI study.
And I think it is mandatory according to API 580 to evaluate the expected damage mechanism by a corrosion engineer.
Yes, exactly. So this is one of the mandatory requirement from one of the standard of API, which is 970 corrosion control documents, which is launched back in 2000 series. That they have to do this, develop this document. The team, this has to be formulated. So this team will sit together and they will see from all aspects, not only from the inspection aspect, from its damage, from their corrosion rate, from the accessibility, from the design aspect. One of the, in each of the engineer, which is the SME, which is a part of this.
So again, those the members of the team, other than me and you, will have process engineer. This is very important to identify the integrity operating window.
Exactly.
Static engineering is also very important for mitigation recommendation or something. And finance, do we need
Safety, process
Process-
safety.
finance
need
is one of
finance?
finance. We need only one basic input, which is in term of the our product costing value there. Because when we are talking about the RBI, we are taking the consequences, and one of the pioneer consequences is the financial impact of your business. In case if this leak occurred in our RBI, what will be going to be the business impact or the losses to us? So for that inputs, we need a financial supports to get these digits and numbers there.
and of course environment. Yeah.
Environment also,
Yes.
which is usually we used to manage, as this team is sometime a multidisciplinary team there. Like process safety guy, he is a expert of safety, environment, and all things there. So he can feed the information related to environment consequences there.
When you start to explain about the workflow and the necessity for having corrosion engineer, we mentioned API 580, we mentioned API 970. Is it possible to mention what are the main governing standards while doing the RBI process?
Yeah, so now let me come up with the concept of the RBI there. When the organization decided that we'll go for the RBI, they have two routes there. Either they will go for the qualitative approach, which will be they will governing the API 580. Then they decide, okay, no, we need to move to the fully quantitative approach of RBI, which will be governing from 581 standard. Now, to decide which standard I have to go, it depends on your availability of the data. Because when you will move from 581, you need a huge multiple factors and multiple data there. Sometimes that's are not available. So in that case, based on your data quality, your quantum of RBI is shifting based from quantitative to qualitative. And that decision will be based on this data, you are able to decide it, okay, we have to go for 580 or we'll go for 581. So these are the two pioneer standards which is governing the RBI Foundation. Later, with the passage of time, ASME, SME section also, PCC3, they introduce the best practices which will be help to them, okay, how to develop the inspection plan. And just recently, there is one API also has been embedded there to define the helping in developing the inspection plan, one of the standard from the
So because of like insufficient data or something, we can start with the qualitative approach, and later on after like rigorous inspection and good inspection data are available, and other data from other disciplines as well, we can have the quantitative
exactly.
assessment.
This is the one of the things there which you have mentioned.
Yes.
Where initially maybe baseline we don't have a good data there, not only the inspection or design or the operational data, but with the passage of time, with multiple inspection, we get a good inspection confidence. We can able to shift it from the qualitative approach to semi-quantitative, where there will be a detailed assessment will be there for each damage mechanism, each deterioration rate will evaluate in the depth, and then our confidence on the risk which we have defined from RBI will be increased also.
So all these data are required to calculate, first of all, to calculate the risk, which is like a combination between probability risk and consequence risk, and then we'll come up with our inspection plan and mitigation action if needed.
Yeah.
So let us start about the probability and how the probability risk is identified.
When we start, this is now what we explained about the RBI work process. Now let us go with the brief level of the workflow. Once team is gathered, there is a two constituents of the risk. One is a consequence, and one is a probability.
Yeah.
So this is we have to be keep, and you will elaborate that by inspection we are adjusting the probability. Consequence is freezed based on the design approach there. So once initial level baseline RBI we have developed it, the consequence will not be in our control to mitigate by using the inspection technique. And as per API 581, we are only focusing on those mitigation action which can be reduce your probability and which will be coming by doing the inspection there.
I think we can understand this from developing an inspection plan or an inspection technique, mean you are detecting a damage mechanism, either at which stage it started or not. So once you are doing that, you are detecting the probability of the damage. But if you did not detect and already the damage happened, consequence is fixed. at the end. Maybe that's why it's not impacting
Yeah, this
that.
this is one of the thing there, that when the consequence is there, the consequence always they are taking the multiple scenarios there. As per 581, we have 4 scenarios there: small pinhole, small leak size, then medium leak size, high leak size, and the rupture case there. So these are the 4 situations. As I have mentioned before, that decision is ours. When we are moving from 580 to 581, which we have evaluating all the 4 cases. But if we are governing the 580, we fix to one leak size there. That okay, let us, based on available data, will evaluate our whole situation of the consequence based on that leak size, which is fixed as per the small, medium, and high, and the rupture case, which is completely equipment occurred. So, if at the baseline level, we are starting with the small leak size, and when we have good data there, we'll move it from small, medium, high, and finally to the rupture.
From this explanation, I get confused a little bit. Now, when you are saying you are not changing the consequence, from what you explain, if you are defining the loss of primary containment, like either a small pinhole or something bigger or so in different levels, means you are looking for the consequence. Each of them has different consequences.
Yeah, this is what I'm telling now. Initially, when we develop the study, we don't know the extent of that damage mechanism. Either that damage mechanism, there is into damage mechanism concept there, active damage mechanism or potential damage mechanism. Initially, when I don't have any inspection history, when we don't have any record of the equipment there, we are defining one baseline. At the baseline level, we consider that this is the potential damage mechanism. When we inspect, that one will be shifted to either inactive or the active.
Okay.
So here يعني there is one point that the best time to have the RBI implemented is at the beginning of the project or during the construction of the plant.
Yes, this is one of the benefit which the industries and owner user is availing it by adopting the RBI at the project level.
Yeah.
That
I believe even before construction, and I believe even if
during the basically project feed phase,
Yeah, in
they
the
will
initial
come up to
thing,
the
yes.
bottlenecks. So I will give one example for that one. For example, we did our corrosion study for one equipment, and as per the process data sheet, he mentioned this is hydrogen service, okay, and it will go up to this temperature. And based on that, he said you can go for the minimum material chrome moly. But when we study this one and we evaluate the likelihood of HTHA, we come to know that this damage mechanism also in the medium category. So we have now a chance at that time to shift it from medium susceptibility to no susceptibility, because initial cost, at the project level, we will have a call, okay, we want to upgrade the metallurgy from the low chrome moly to 1/4 moly to 1.5 moly, we can shift it there. Because once the study done based on that material, everything will be reversed in the later stage when it becomes in the service.
But isn't this example somehow should be part of the material selection? Such a thing, such a consideration doesn't require RBI study to know. For such case, it is a philosophy for how much safety margin you are considering while selecting the proper material.
Yeah, this here now the jump in our integrity operating window, which is API 584,
Okay.
because when the process and design engineer is there, process engineer will give you in the designing of equipment, this is my design pressure. So designer, considering that design pressure, he will calculate all the study. But within this design pressure, some of the damage mechanism will be shifted from credible to active. Before it is inactive, but when it come into that range, this damage mechanism will become active. So that level, they will define these integrating operating windows that you can operate within the design pressure, okay. But below this design pressure and in between the operating conditions, there is a window where these damage mechanisms will become activate with the accelerated phenomena there. So during that initial selection, they are always not considering to the full-fledged zero elimination, with the medium elimination, because they have their own parameters to design the equipment within their resources, and that with their
But this raises another type of question, like during the material selection itself, shall we consider the design condition or the operating condition? For example, if we're assuming we are taking the design condition, which is the most extreme condition for the equipment, including one additional safety margin as well. So somehow integrity operating window will be under this condition.
In-
So if you are working in design on this level, so all whatever lower should be in the safe condition.
So here the good question is, because see now what now coming to that part, the damage mechanism identification part, the you need the designer always considering the maximum safety margin there in terms of this their mechanical aspects there. But this part, the corrosion part there, some as I mentioned the integrating operating window concept there, that will initially in the design phase is inactive. But if that exclusion from the process occurred, it become the activate there, which initially in the process cannot respect. One of like a situation I will like to quote here in my experience. That material was, there is no chance of chloride emendation in that initial process based on the process feedback. So designer considering that aspect, zero chloride or zero exclusion, he select the austenitic low grade material 304 or 316. But later due to leak in some other equipment, that chlorides travel in this system. So at that time what happened, these chloride induced one damage mechanism in that, which is the chloride SCC, and that situation activate the cracking phenomena there. And here the designer considered the baseline from the process, which is no chloride exclusion. So this is one of the.
That is a more clear example.
So this is one of the tool which will help at that level. Okay, there is a chance of chloride addition in this system there.
Yeah,
So same thing in the HTHA, which I quote also there, this phenomena there. Like earlier, if we go back in 80s, when carbon moly is a pioneer, if you know this one is a pioneer of the material. So there is no chrome moly introduced. So the designer select always carbon moly.
Yes.
So later when they see this incidence of HTHA from the Nelson curve, they come up, no, this is, we have to see some other superior material. So
now we are struggling with all the plants with such.
yes, exactly. So you imagine now this is one of the example. Like if at that time they have a concept of this damage mechanism, they will think on it. Okay, this carbon moly is prone that one. So let us go for one superior. Although it is meeting my minimum design condition,
Yes.
but it is in fact adding my another issue, which is the HTHA.
Yeah.
But now you imagine these equipment which is already commissioning and running, you have to now invest a huge money to change its design, and it's not only changing that individual equipment design, there will be a lot of changes will be occurred there.
If the philosophy for this material is embedded in a plant, you need to expect like a very good part of the plant constructed for this.
So due to this reason, now the people and the owners, they are in emphasis is that let us apply the RBI at the design level, because at that time we have a call, our resources, like if later I have to spend millions, now I can maybe spend in minimum numbers and I can directly go for that change which I have to do after 10 years or 20 years that long.
I think Bahar explained earlier in previous sessions why it is important to involve mechanical engineer during the when establishing a data sheet.
Yeah, so they are not recognizing our role. This is the issue. They need us.
But this is a good thing. What Saqib is explaining here, that you have a full team.
Yeah.
When you have RBI study during the engineering phase, you have a full team of corrosion specialists, environmental engineers, and mechanical engineers, and
Process safety, even as a part of PHA, they are also available at that time.
and process, of course. So you can capture all these things and all potential damage mechanisms and expected damage mechanisms that may occur in case of any failure in one of the equipment. So this is very good.
Yes.
Yeah.
So-
Okay?
But one thing, I'm sorry, before leaving this point, now let's say you are adopting the RBI during the very initial stage of the plant design in the field also. At this stage, you have possibly only the P&ID.
Yep.
So many assumptions you need to make about the piping, possibly some configuration of the equipment, how it could be there, and this will impact greatly your evaluation for the potential damage mechanisms might be there.
So if I will talk about the API 970 Korean control documents, now just I will add to one more thing also. This is now the company is now adding one of our deliverable from the projects give us the corrosion control document also. When this system, this 970 is launched, this is now start added by owner user to one of a deliverable from the
we
feed
were
phase.
earlier struggling for the material selection
Diagram,
What
exactly.
doing?
So this is one of the, as you have mentioned, that we skipping the many areas there, like material selection diagram is done there, but maybe some in draft form. It is not a controlled document. So 970 now mandated these all documents should be controlled, and if there is any changes later stages, all has to be reviewed. It should not be only reviewed on the PNID. You have to review again the MSD, the corrosion control document, which is the CCDs, IOWs. Everything has to be reviewed there.
That's very important thing. You know that sometimes when you are doing in some studies in later stage in a running plant, you start to think about why the designer select this material. What happened there? You need to think about what was in his mind. You cannot find so you need to put an assumption. Maybe he knows something you don't know. You have previous experience of damage you cannot recognize. The material is not matching with the service in a way that you can recognize the damage mechanism. So such documents, I believe, from the corrosion control documents should provide at least a proper explanation for the team who will work on the plant in later stages.
Yes, exactly. So this is, as I have mentioned it, when this is knowledge when the people will learn from the basically from the lessons there.
Yes.
So initially when there is no concept, if we go in 1980s, there is no concept of inspection. So it shifted from inspection and then RBI. When RBI foundation laid, at that time they come, oh, we have to implement this, we need this 1, 2, 3 documents. So okay, from where we'll get, then this system, then API has launched this 970, the corrosion control document. It is a nice one document. And again, it is a best practice. They make it as a best practice there.
Yeah.
So now the owner
Company
user,
need to adopt it.
company need to adopt it.
Yeah.
So in that there is a very detailed workflow. They have mentioned it. Okay, this is the documents which is expected outcome, and it should be a part of the project feed level there. Because as you have quoted, that sometimes designer assume MSD based on certain condition.
Yeah.
And if you see
You don't
many
know. Possibly is right or wrong, but
Is right.
you don't know. If you find a strange material or a material higher than how it should be, you need to start to worry. Why is it?
This is one I will like to share one of my lesson during my past experience. The licensor was confirmed, okay, this material is compatible, stainless steel is compatible for my service. He is strict to that one.
Okay.
But later when we found that damage mechanism during inspection, we give it to them. So what he did, he proposed all of the metallurgy in whole world, their plants there. Gentlemen, this is, you have to do it. So I worked in one petrochemical plant.
I faced similar cases.
Similar
by the way.
cases
I
where
faced
you will say
similar
also.
case, yes.
So by adopting this, our lesson learned, they are changing the foundation of their MSD, PNID,
Exactly.
everything
It
is
happens.
changing.
Yes, it happens.
So the concept of this, and if we catch it at the first phase, no need to go in the reactor
You know
phase
the
in the
issue
last.
that in this case the licensor responded to you, so he give you somehow some good confidence for what you are doing.
Yeah.
In other cases, if you are not there or they are not responding, some of the plant team will start to assume, no, if there's an issue, licensor will not use it in other plants.
In the other plants, exactly.
But,
So this is
industry actually is evolving, and the experience is evolving. Yeah.
so this evolution, which is because licensing is also they are the engineers, they who develop it based on certain experiences. But now the era is changing. The things has been changed a lot there. We have to adopt all these changes there.
Yeah.
So this is one of the things which I suffered with that licensor. So at that time we predict this, and that was stainless steel, and he was strict, no possible. So we upgrade to duplex. So what he did he launched one of his revised specification in all of his plants in the world, and they enforced them. You have to go for this metallurgy because this damage mechanism will be there.
Yeah.
So imagine if this is done in that initial level, all the efforts of this re-engineering, everything will be saved at that time. So this is one of
had they done RBI, it would have been avoided. I mean, Mr. Saqib, he said a very important thing, and I would like to emphasize on this. Without RBI, we learn from our failures.
Yes.
We take them as lesson learned. But with RBI, you can expect what is going to happen,
Things are
and you can use the minds of your experienced people to avoid such failure.
Yes.
So
Yes, exactly.
this is very important.
Yes, exactly.
in our
So this is as initially
in a
the
proactive way instead of reactive.
so as I told you, this RBI, some of the hidden advantages are also there with us. Like I will just quote one example recently which we suffered it. Sometime stainless steel, Mr. Bahar is our design engineer, he know about this material and the selection also there. Stainless steel, usually we never expect the corrosion there. So based on that assumption, the designer, the detail engineering engineer, he used to keep very narrow margin. But with passage of with the inspection confidence, with the inspection finding, we come to know no, there is some damage, some corrosion is occurring in this. So at that time, we need to exceed the tolerance margin, because if you know this one, when calculation is required for my stainless steel, it's coming 3 millimeter. Designer will give you exact 3 millimeter nominal thickness. He said no corrosion, so he is expecting 3 millimeter, but in actual it is there. So in such situations, it is feeding to the design team also. Hey gentlemen, there is either you need to think on another solution, either upgrading of the material or increase your thickness near to more than that one. Yani corrosion allowance, which is the basis of that design initially, you have to consider the corrosion really occurred. So this is one of the feeding which indirectly can be given to the design team at later stages. But if this all exercise is being done at the feed level, we'll avoid all this reworking or redesigning everything. So this is just I would like to share the things there. And now we covered this our concept. Now every technique has its limitations and it has I can use the word, its exclusions there.
Yeah.
So one of the pitfall from the RBI, people will think it will cover every universe. So it has some own limitations there. So one of the limitation in the RBI is whenever first I will like to highlight here, we cannot cover all equipments in this. Certain equipments cannot be covered, like for example electrical equipments, instrument based equipments there. Some rotary equipments, other than the pressure containing casing, we cannot do the RBI study. And sometimes people are intermixing the one. I will like to one thing here, the other techniques. There is a concept in the process safety, PHS and the RBI. Little bit seems both techniques are similar. So it has own domain. So actions driven from PHS should not be mixed with the RBI actions, mitigation actions there. So there is a boundary should be clearly specifying here that outcomes or actions both should be treated separately there. So
and as you said already, the casing or pressure casing of rotary equipment, so also interaction with RCM. So
yeah, exactly. There is other material
done with the RCM, with somehow it is with different flow, but it is a similar thing for the same object.
Same one.
Yeah.
So this is as our intent of RBI is to avoid the LOPC, loss of primary containment there. So all these things with certain limitations, we are not able to do it for some equipment. Even for some of the static equipments, sometimes RBI cannot be a mitigation tool. So I will like to specify here one example in my history there, what we did it. We have one heat exchanger there. So we did the study, okay. Later when we did the study for that equipment, we identified the risk and we develop, when it comes to developing the inspection plan, it is a shell and tube heat exchanger. We recommend to do the tube testing. So when we going to do the tube testing, we found the inspection cannot be executable there. Okay. Because what they did it, they provided dummy tube sheet on the tube sheet there, welded one. So you cannot insert any tube testing probes to access the tubes. So in that case, what is happening there, RBI cannot meet it, because I recommend to do the tube testing as a mitigation action, but it is not executable. So in that cases, this is one of the feeding system for our engineering team also. Okay, hi guys, this equipment is under risk. We cannot evaluate the condition of the tubes. Think on another design. So in that case, what our engineers did it, they study that equipment. They see the concept why this is welded. Can we go for some removable concept there? And then they shifted it from the welded to the bolted arrangement.
So this is a good example where we can have like a risk evaluation after inspection, and we should understand that the risk is dynamic. So what was like minor can become like significant or major in after the next or the upcoming RBI study, and we can, as an output of RBI, you can come up with a mitigation action to have this inspection, to make this inspection possible for the tube inspection?
No, this is basically we are triggering another system there, which because this all asset integrity is coming in asset life cycle management concept there, starting from the design, operate, maintain, and retire. So we are at the maintain level. Now we come at the maintain level. RBI is basically coming under the umbrella of the maintain. So we are failed to maintain means fail to inspect it. So which means we'll go back to the first level, which is design.
Yeah.
So they have to at that time the redesigning concept will be triggered there. So what as I code the example what I code there, we triggered the redesign, and at what happened, the detailed design approach is carried out, and that welded arrangement has been shifted from the bolted to facilitate to in the inspection for maintaining the equipment and to get a good inspection confidence. And when we get more inspection is basically if I will see the graph of this residual inspection and the risk, it is inversely directly proportional to the inspection. We have one API 580, we have one graph there. If we go by typical inspection approach, more inspection, whenever you do conduct the inspection, the risk is reducing.
Yeah.
Yes.
But at certain level, the risk will be no further reduced there.
Yes.
Why? Because now this risk, we reduce the probability as low as possible.
And when inspection cannot reduce the risk any further, we have to come up with mitigation.
Mitigation, exactly.
But we have also, like, we have a case of like some damage mechanisms cannot be reduced by inspection. Maybe fatigue crack.
Fatigue, exactly.
is one example.
So yeah, this is.
So it's in API 571. The how to avoid fatigue. You need a good design.
Yes.
As we discussed this before, now coming to this very good example of fatigue, if I did the RBI during the design phase, what will happen? The designer will consider this and he will add the other mitigation action of engineering at that level, and will not come up at this level that we suffer the cracking, because fatigue damage mode is cracking.
Yeah.
So all these, if it is captured at the design level, these things will not come to at
but
the
even if it's not, even if we're doing RBI for an existing plant or for running plant, we can
identify
consider this, we can identify this and consider this for like upcoming opportunity.
Yeah, exactly. This is as I mentioned that the side product, I will use the word, is the side products of RBI. They are helping to identify the design deficiencies in our assets there. And at that time we can trigger this one, our approach of review the engineering solutions, or some non-engineering solution, not always limiting to the redesign. Sometimes there is some operational controls also there. Like for example, I will just like to quote here one very good sulfuric acid corrosion which occurred with us in our one process in stream. So the best for this concentrated material, sulfuric acid, the best material is carbon steel.
Yeah.
But what happened if we upgrade? Upgrade to metallurgy. We are activating another damage mechanism. So what is the solution for that? You have to maintain the concentration. You should not reduce its concentration from certain to make this damage mechanism the active. So we recommend that to the operation. Introduce some this removing the oxygen or the dilution phenomena, which is their standard SOP. So it trigger revision of their SOPs also there. So this is, as I mentioned there, these are the other mitigation actions other than the inspection and the redesign.
Of course, the best material, not only from corrosion perspective, but also
cost-effective.
Cost-effective.
Otherwise, there is no engineering
it's good, good enough. And
this is sometime the example. Sometimes people approach is okay. We have this issue. Upgrade the metallurgy. Mm-hmm. I will just like to quote one example.
By the way, it is not an easy decision, and many times some people take the decision like, yes, this material is having an issue. Now I'll go to the higher material. Then, when other damage mechanism happen, you will discover what he missed.
So same thing I will quote here. We have one vessel there. So there is internal corrosion occurring there. There is a sware corrosion. It is basically in the service of wet CO2. So wet CO2 corrosion is occurring. The construction was carbon steel initially. So the detailed assessment has been carried out, and they say, okay, let us shift it. It is insulated vessel, okay? It was insulated vessel as per process requirement. Let us upgrade to stainless steel. So they upgrade to stainless steel. But what they introduce? External chloride SCC.
Yes.
Because you know this damage mechanism still in the API 581, there is no good inspection effectiveness. And API clearly mentioned there is no such inspection technique to give you a guarantee that external chloride XCC is eliminated from your system, which is more dangerous. Initially, I am seeing the internal corrosion, I can see, but now I activate external chloride SCC due to upgrading.
Yes.
So now, if at that level we have this concept of corrosion control document, call will be taken. Hi guys, don't go to stainless steel there. So this is the importance of you realize that if this study has been carried out at the initial levels, design phase, we can take the call can be taken. You are fixing one issue, but it is shifting to more dangerous issue, which you know the external chloride SCC cracking. So, and it occurred in that equipment later stages. What happened? They were expecting there will be why this now we upgrade. So interval should be very high and we should have very less inspection. But due to this damage mechanism, instead of getting high interval reduced.
Yes.
It may come maybe 4 year, 5 year, which is supposed to be initially 10 years. So this shows the importance of the corrosion control documents in all aspects, specifically when you are doing any modifications there. And API has realizing these things, and due to this they are launching the new, like recently which I quote 970, they launched this best practice there also there. So this is now one of the part which we had discussed. Now coming back to this the earlier question, from inspection we can reduce the risk up to certain level. If I will do further inspection, after that the risk will increase. What does this means basically? It means now I have one equipment, I did 10-15 inspections and I reduce its probability to the lowest level. Now if I do further inspection, I am introducing the more risk, yani more chance of LOPCs there. Example which I quote here,
Yes.
low oil coolers, these are very clean. There is no any chances of any active damage mechanism there, we inspect it.
And
But
in most cases, stainless
steel there. But what happened, we inspect and it comes after 2 inspection. If I will still open it, there will be a chance I will add some other impurities in that. One of the example which I will quote especially, initially there is no chance of chlorides in this. During hydro test, when you do the inspection, we are adding the potable water, mostly due to chances. And industry practices mostly they are at that time ideally the stainless steel equipment should be hydro tested with dim water, but during the outages to manage this is very difficult. So they did the hydro test with normal potable water and chlorides added.
I need to catch you from this one. Is the hydro test part of an inspection plan usually output from RBI to do hydro test?
Yeah, this is very good question. We have actually, if I will go back to the PCC and SME 510 or 570, hydro test is usually always required whenever you're doing touching the repairs there as per the definition
So
of
it is a
510.
qualification of repair, not an inspection.
Not
to
an inspection.
detect
But what industry practices are there to get a good confidence of other entity techniques? They are adding this as with their own internal procedures there. They are not going for 1.35 as per as we see. It has to be 1.3.
Here is the issue.
Here-
You will open another chapter with its complexity.
Yeah. So how what was the industrial practices there? They are not going at the hydro test pressure. They are naming as a hydro test. As per my understanding, it is not hydro test. Hydro test is when 1.3 of the design. But what they are doing they are doing the leak test basically, giving the pressure at operating the pressure, or giving the some 1.1 of operating. Some industries have a practice like if I will like to mention in my petrochemical, we have one corrosive. We know this equipment has some issues. The corrosion rate is there. After this one, our practice is we are going for 1.1 of operating for that unit. But other units which we have no corrosiveness, to ensure its integrity, we are going for design pressure only.
Yes.
So this is to get our confidence of our tests, because some of the entities it is subjective to the operator. Like example UT. Our inspection plan say do the ultrasonic testing to detect this damage mechanism. Now I'm dependent on the operator. If his mood is good, he will say all okay. If he has some personal issue, he will put some findings there which is not existing. So it is dependent on the operator, and even it is clearly mentioned if you go in the 572 and 574, which is the inspection practices for vessel and the piping. They are telling this. This technique is very good technique, but only issue is you are relying on the operator there. So in these cases, when there is a operator confidence is linked there, so this leak testing concept or the so-called hydro test concept is embedded in the inspection plan.
Okay.
So how new techniques or how inspection techniques are captured in RBI, like the new techniques recommended by API 941, for example, for HTHV? How are you considering these new techniques
this is the very good question. Now what we are basically in the RBI, one of the product also, because RBI is optimizing the inspection plan, so we are introducing the non-intrusive inspections also.
Yes.
But there, if we go 510, there is a certain 11, 9 or 10 requirements there. If that is meeting, you can go for the non-intrusive inspection of that equipment there. And 581 is also talking about in that part that if you want to inspect this damage mechanism, you can go for this non-intrusive inspection. I will like to quote here the one example of COI, the corrosion under insulation assessment there. We'll discuss I believe in the detail about how we are evaluating it, but I will just like to mention it. Like API 583, which is launched recently to check the corrosion under insulation for suspected areas by stripping of the insulation. So there 581 is adding, jumping in, and they are telling and they are recommending some inspection techniques which will remove this requirement of insulation removal.
Yeah.
Like Lexi profilometry. And then we have certain COI assessment advanced entities there with proper qualification. All this basic requirement is all these techniques should be qualified before as per the governing standards, which is SB5 or the procedure, the calibration requirement there. Then you can implement this. So this is one of the outcome of the RBI, that it will eliminate the internal inspection also in some cases.
But we have to keep in mind that this non-intrusive inspection is only applicable for ferritic steel. I'm not sure. Do we have non-intrusive inspection?
No, one requirement for that is you should not expecting any cracking. And in ferritic, so he eliminates this requirement by stating this: if your equipment is not prone to cracking phenomena, you can do intrusive.
Yes.
So always austenitic stainless steel, the damage mode is cracking.
So till now, no non-intrusive inspection recommended by
exactly.
Yes, for austenitic stainless steel.
Like what I quote the example for CUI, for ferritic he is talking about, but when it comes to austenitic, he keeps silent, and he write even in the 581. As of now, there is no such technique, non-intrusive technique to identify the austenitic, the chloride SEC in the austenitic steel. So which means standard also know the limitation of the techniques there, and they are clearly specifying in their governing requirements for that. Which I explained that you reduce the risk up to certain level. Like Umar asked, okay, what is next now? I reduce it to this. What is the now next?
Okay.
So here then you have to, as we discussed, I explained, risk is combination of probability and consequence. So you take all the credit of probability now. Now which is the second part we have to touch? Consequence.
Can we reduce consequences?
Yes. Consequence can be reduced by, not by inspection.
Not by inspection.
There is some other technique, like I will like to quote here. Okay, I have one some toxic vessel there, contains some toxic material like ammonia or some CO or some H2S. So after getting the probability confident up to lowest level by multiple inspection, now risk is still high. So here RBI has one limitation, that such equipment, because as I mentioned, RBI is using only the inspection technique to mitigate the risk, not other. So here RBI will raise the flag, okay guys, we reduce this risk from inspection up to lowest. Now it come to which? Asset life cycle design. So what they have to do, like what I quote, it's a toxic material, they can introduce some protections there. What is the protection? Okay, if I have a release on this, ammonia will come, okay, I have a deluge system. It will suppress the consequence of the spreading of the ammonia. Okay, if we have this, okay, install the dike. So you will avoiding the primary containment loss. You are adding the secondary containment. Like I will like to quote here, we have one sulfuric acid tank there. So how we mitigate the consequence? We introduce a second tank on that. So that tank, initially primary containment is there, and outside there is a secondary containment. So that is basically a mitigation for us to reduce the consequence of spillage of sulfuric acid.
Okay, but here we should notice here that sometimes new regulatories or new requirements in the environmental regulatories can change the risk level as well.
Yeah, exactly.
Like for example, this definition of secondary containment, there is like a controversial term in secondary containment, impermeable or impervious, like secondary containment. So that definition, does it mean that we need to have an HDPE liner under the bottom plate or not? This is a new requirement and they make it mandatory. Now because it's mandatory and we don't have it, now the risk has changed and it is increased. Maybe we need to reduce it by having a mitigation action.
So,
yes.
Yeah, exactly. So this is the very good example. Why now? Let us dig out further. Why they mandate this LDP liner there? What happened in that case? There they see, okay, you are doing very good inspection, and still you are doing the consequence to environment there. Yani if you have a very good confidence, but if any overfill or something occurred, my environment is contaminated, which means environmental consequence is high.
Yeah.
Okay, so consequence high, risk will increase. So this is named as the residual risk of that equipment. Inspection cannot reduce further. So they mandate add LDP liner. That LDP liner, HDP liner, what it will do? It will reduce the impact of the spillage.
But that's fine for the new tank. The issue
No,
I have an existing tank.
again coming to that part. If we did the RBI study at the design level, will not come up this.
Yeah.
Well, it depends on
this is the
it
example.
depends on the requirement of the
Yes.
environmental regulatory. Sometimes they make it retroactively for existing plants and existing tanks. You have to comply with these requirements. Sometimes they make it
just imagine you have in a hub or something, and you have many tanks, 50-meter dia, 60-meter dia, these huge tanks, and it was designed 15 years back or 20 years back.
Even if you,
what you will do?
Even if you see in the
this is a challenge. And this is.
But if you see, if it comes to regulatory requirement, all code and standards will raise the flag. If you go 510, they are clearly mentioned. If your regulatory requirement is governing, this code is not applicable. Same way I believe in the design codes also. But in all inspection codes, always upper hand is regulatory requirement.
Yep.
So they have rights, and whenever they are adding any requirements there is something behind, some process incidents there.
Yeah,
That's why
we
that's
can
why
understand,
we
but-
cannot
but you don't know how to do
we basically receiving their directly recommendations there. But what is happened behind, that was one not aware. But as this now example is very good. If this all things happened during initial level, we will not come up with this mess up in the last when the asset is about to retire, and then we are recommending these some things there.
But sometimes it's a new requirement. Like, okay, so the example I shared with you is maybe new requirement.
So in that case is what the regulatory requirement, now it comes to our the process owner industry requirement there, evaluate the risk of this requirement. Maybe sometime like what you mentioned, HDP liner issue, okay, they say you have to put this because we have excess industry issues of the environmental, but we have already other mitigation tool. For example, I have a dike available, I don't need this. So in that
You
case,
still
No,
need it.
even though
need it. You could
you
under
still
the tank.
see, you still need it. They'll not mandate, not necessarily to mandate like HDPE liner of some thickness, for example, but they'll give you a definition for what do they mean by impermeable secondary containment.
containment, exactly.
So even this definition is not the same if you go like from country to country or from state to state. You will have different definitions for this, and the result is different consequence risk every time you do the RBI. So what I mean to say that this is something you cannot capture during the design, because it's a new requirement.
It's a new requirement, exactly.
So, and if it applies for the existing equipment, you have to calculate the risk and come up.
Exactly.
And if the risk is high and reaches the unacceptable zone, you need to come up with a mitigation action to reduce that risk. There is no other solution.
So this is the same thing, but you have quoted it here. The regulatory body, they will tell you our requirement, but sometimes we have another mitigation available. Like I will quote one experience with my one regulatory body there. Their requirement was there, we have this internal floating roof tanks. So they say we have to inspect that secondary seal every year, which means to inspect this, you have to open that tank. So imagine the tank internal inspection usually 10 years, more than 10 years. So every year. So there what happened, there was a technology innovation occurred there, and they have launched some robotic crawlers to inspect the seal. Their requirement was to inspect the secondary seal there. So that seal now, how it is going to, is inspected it by using that robotic crawlers. So that requirement is fulfilled by using this technique. No need to open the tank for internal inspection, because opening of internal inspection, for the tank is a huge maintenance
there is a solution. For other cases like this, HDP liner.
HDP liner, yeah. So it can be, we have to not argue with them. We have to justify them. Hey guys, we have another protection for our this risk. Sometime for regulatory bodies, they will be understand and they will accept it. In some cases, they will maybe give you the time for that.
It is a tough thing.
Tough thing. It is really tough. And even you see the code standard is raising the flag. You say, when it is a regulatory body, I will keep quiet.
Okay. Also in a previous podcast, in the podcast for urea plant, we covered the leak detection system.
Yes.
And what do you think? This will also reduce the consequence risk.
Yeah,
not the probability.
Yeah, exactly. This is the very good thing. Some of the cases there where you cannot control that damage mechanism there. Like we have got a very good example of the urea reactors there. There, our this condensation corrosion and this urea corrosion cannot be avoided 100% there. So which means I cannot prepare very stringent inspection plan for that equipment. The damage mechanism there cannot be eliminated, impossible to eliminate. So what they did it there, to control the risk of that equipment, they mitigate the consequence by leak detection system. What is this leak detection system? Then in that equipment, we have a robust leak detection system there, that whenever this the carbamate or this unstable urea comes in contact with my corrosive, with my carbon steel, immediately we have to take the call of the stopping the process or do some operational controls.
But this is the like the end of RBI. It will not give you any
exactly.
further
This is now. This is as I told you, the limitation of RBI. Sometimes you have inspection limitations there. You cannot eliminate, you have to live with that risk. So that damage mechanism, we cannot eliminate. There is not any, as of now, even the licensor is also did not introduce such any material which he will declare this is 100% prone to this damage mechanism.
No, I mean if the damage mechanism is detected during inspection or during normal operation, this is out of RBI scope.
Exactly.
This is the limit of RBI scope. Beyond that, you cannot have nothing from RBI. You don't expect
there is no more inspection you can do. You need to take action now.
Yeah.
So here the RBI in 580 they are talking about. They are telling this terminology in the short. RBI cannot implement for consequence dominated risk. So whenever there is a consequence dominated risk, RBI cannot be acted as a mitigation tool to reduce the risk. So in that case is how the designers or these guys, they are controlling the risk by introducing these leak detection systems there. Even in the same concept of leak detection, we have the credit available in APA 653. In the bottom plate inspection, the minimum requirement of thickness, if we don't have any protection, is 2.54. But if we have some this leak detection system or we have a coating, the code is allowing you can go to this level of minimum thickness there. So this is a credit of the engineering controls which can help to take the credit during our assessments there. So this residual risk, as we mentioned, it will not be further mitigated. So there you will trigger what? You will trigger the asset life cycle concept of the design, operate of that. So this is one of the concepts. Here I will like to add one more concept of ISO risk there. What is basically ISO risk? As I mentioned before, that 80% of the equipment's risk of any facility belongs to 25% of equipment. So this is one of the fruit, I can use the word of RBI. You will get your ISO risk line there, and you will able to distinguish all these assets are above my risk level. In these I have to focus all my inspection resources. Rest of below, what is below that one, it can be with extensive intervals there, or in some cases you can keep it run to fail. Example I will like to quote here. I have a one heat exchanger which is in the hydrocarbon service. I have one heat exchanger in the low oil. Same damage mechanism assume we have, and consequence of this hydrocarbon is more. So I have to focus on that. This one I will keep with the high interval frequency there. And again, now here API 580 introduced the new concept of a evergreen. Earlier what happened? Below the risk, ISO risk line, all equipments are kept as it is. There are no concept of re-evaluation there. So what happened with the passage of that and for example, we did the RBI study and we set the interval of that equipment as a 20 years or 15 years as outcome of RBI. So which means till next 20 years, it will be not open for inspection, it will not go for under any surveillance. So what happened with risk is a function of a time. With the passage of a time, risk is changes. So RBI 580 here in recent edition, they introduced the concept of evergreen. What they mentioned, those equipments where your RBI frequency is more than 10 years, you have to reevaluate the risk not more than the 10 years. And they introduced this as a evergreen. Because why they introduced this? Those equipment which is below the ISO risk line, their risk may be changed.
So even if the interval is more than 10 years, that doesn't necessarily mean that RBI will not be conducted after 20 or 15 years. We have to conduct RBI at a maximum interval of 10 years. 10 years. So yeah, I get it. So we know that inspection or major turnaround or something will trigger the RBI, and we have to do the RBI study and revalidation after each inspection. But what other factors that can trigger RBI?
So this is RBI program. When we are developing the RBI program there for implementing, there is a multiple triggers there. Like for example, as you have mentioned, after any inspection, you are revalidating your study. Second, which I have quoted one example here, this evergreen, you have to take the reassessment of those equipment, because initially that is low risk. But maybe now some exclusion or some things have occurred and risk will be changed. The third important thing, those equipment where there is a deviation from the IOW, which I quote. You remember I quote the example there. Initially there was chloride embedded in the system, so there was an interval considering without chloride SCC there. So those equipments we have to reassess the risk level, because new damage mechanism introduced in that equipment.
Yes.
And one of the fourth requirement is, even if we develop a very robust system there, still there is a chance of loss of primary containment, which may be due to other factors. So those equipments where this LOPC occurred there, we need to revalidate its risk level. Maybe we missed out some damage mechanism during our initial baseline RBA study, or maybe we underestimate the consequence.
Okay, let me ask it let me put it this way. Like if we have a vessel or an exchanger, or loss of containment incident happened in one exchanger or one vessel, do we need to consider other similar vessels? Will this trigger the RBI for the similar vessels in other plants, for example?
No, here the things jump in for the concept of a IOW. Yeah, I get your example. If I have a failure of one equipment in one plant, it doesn't mandating that it occur in all the plants there. Here the concept come up before triggering the assessment for that. You need to dig out, okay, this issue occurred. Is there any deviation from my integrity operating windows? That's why this issue occurred there. So by adopting this concept there, you have to evaluate the equipments which is prone to within that circuit. Maybe in other areas you need to check the IOW deviations. Is it occurred the IOW deviation there? Then you need to re-trigger its risk and RBI and inspection.
I mean, if it's something like was not considered, if it's something no one considered, it failed because of something we did not consider in our RBI. And I think the same had happened for the other similar vessels or equipment in other plants. So it makes sense to go and do the RBI
Again,
for
in
this
that
equipment.
cases, we will not revalidate we should not go for the RBI, or we should not go for the inspection there. We have to review our corrosion control documents. You get my point there, that this issue occurred in this, okay, which means this damage mechanism occurred, okay.
Which is an input or main input to
Input
the
for the
RBI.
RBI.
So once it is reviewed means you are triggering
The RBI there,
Yes.
exactly. So this is what you will do. You will open, you will revalidate that circuit, okay. You will rule out, okay, this damage mechanism. Like example, in where this failure occurred, the material is carbon steel, but that second licensor, he know this. He put there the upgraded material there. So that, which means why I have to inspect that line, waste our resources and do the change the risk based on this incident. So you revalidate your corrosion control document, and when you see it is implement, then trigger the RBI, then trigger the inspection. This is a integrated process basically how it should be worked in this pattern, and it is adopting here. Again, what the industries are doing it, when they are any issue occur, they are touching initially to corrosion control document. And in that cases, they are specifying this damage mechanism is inactive. Now this incident will change it to active. So that active damage mechanism occurred, you will fit this active damage mechanism in your study, and based on that your inspection plan and all your execution will be has to be changed there. This is how it is integrated workflow there.
I mean, from inspection point of view, like if we have a vessel or exchanger.
But by the way, he's saying exactly what you are saying, but he took it from the little bit more global view of the RBI.
Yeah.
He's saying you find an issue there. Before saying this will happen in this equipment, I need to evaluate everything to say it is the same.
Yes.
What you are saying, you have done this one and it is exactly the same. So it is triggered. So if it is exactly apple to apple and
Apple
happened
to
here,
apple,
means
yes.
you missed
You
it,
missed
the
this one,
mechanism.
exactly.
So
Yes.
it makes sense that you need to consider
makes
and
sense,
say,
exactly.
but what it's saying, before assuming here similar equipment will face exactly the same, you need to reassess the study and see what are the differences between the both cases to say so. It's almost the same thing.
RBI is a flexible tool, and you need such tool for a dynamic risk. So this need to be like evaluated every time, as you said. Many things can trigger RBI,
Yeah.
and RBI is
Even periodical.
yes.
Periodic.
Even periodic.
This periodic also, which I will like to mention, some of the industries what they limit, they modify the Evergreen requirement. They modify Evergreen is there, okay, but after every 5 years, if it is your last analysis is past the 5 years, revalidate your risk. They are more stringent on doing the reassessments there, because see, reassessments, our resources will be limited there. Instead of waiting for the failure or doing extra inspection there, because as I mentioned there, extra inspection also sometimes introduce the additional risk there. Too much inspection, if you will see in that chart also in the 580, more is there we are graph where risk will be reduced. So if you do further inspection after that, the risk is changing from the other. So at that level, we have to stop our execution or inspection plans there. We have to manage our assessment confidence there.
Makes sense.
So that's the concept where, because as you know, RBI, one of the main output of RBI is optimized inspection plan. So if I will adopt that practice, this failure occurred, then I will open all equipments of all the plants for that, which means the main intent, optimize RBI inspection plan cannot be achieved.
One point just to make it clear also here. Usually, and the normal thing, at least for the big companies, that they are using softwares, and there are many software providers and other companies explaining what might be the difference between the capabilities of each. to which extent the role of the software is important, and what exactly its role in the process which we explained.
Yeah, exactly. Now this question, if you go back when initial discussion, I discussed about the quantum of RBI and availability of our data.
Okay.
So there's a lot of softwares in the market available which they are claiming a lot of things. Okay, we can go for this. When you are going, your organization is going to selection of the any enabler, that time you have to take the call based on your available of data. Like there is many software which is governing from 581. I will purchase this software, but I don't have that information which can be feed to that software there. So which means at that time, based on your available initial level of data, you may be select at the minimum, but with the passage of time, when you see good data available in terms of the damage mechanisms and current control documents and inspection record, inspection history, then at that time it can be switched from quantitative to qualitative to quantitative phase.
Okay. Again, for the same point, can the software cover the gap in the technical part of the team? Can the software identify a damage mechanism the team itself or the SMEs working cannot do? Or the main point of the software in the calculation? You are feeding the inputs, and based on the software capabilities and whatever database built in there for how to calculate different probability of damage mechanism to reach to some method of calculation and so on.
So basically what the software is nowadays, what the software level in the market, they were calculating probability and consequence also. So what they sorry, so consequence basically what they used to do, they have multiple consequences there, economic, environmental, safety. They have embedded some calculation based on the 581 consequence evaluation part, the pool area calculations. So you will plug certain value inputs. Based on that input values, it will calculate the pool area and consequence ranking. This is one part of the consequence. Second part is the probability. So in this software, it will calculate the probability of the damage mechanism. Some of the software there is fully quantitative evaluation as per 581. Some software they embedded their customized workflows, like take this input, rank this probability. So it depends on your available of the data which you will select. This software, or some companies even they are not using the software, they are using normal generalized softwares there, which is MS Offices and this one. They customize the templates in the Excel and they are using
We
that.
should not assume that software can cover a gap in the, let's say, the capabilities of the team working on the process. The team and the capabilities of the team and their work is the main thing, and nothing will cover this gap. It will help in the calculation, it will help in possibly in the screening, possibly it can help on that.
So basically software will facilitate the assessment
Yes.
and documenting the assessments there and integrating the other systems there. This is the one
I
of
have
the
seen some companies just marketing to their software like it has many capabilities, will
Exactly.
identify the damage mechanism for you, it will calculate everything for you, just tell me the process.
But regardless of the system, we rely on the competency of the team members when it comes to RBI. It's not the system. The system might have like features that can make you or help you to run the study a lot easier with shorter time. But it doesn't mean that you will do better in a different system. You will have the same output regardless of the system.
risk and the inspection plan.
Yes.
Like I will just like to quote here one of the key companies, founders of the RBI, they are not using any softwares. This is what we saw, that these are the company which are famous. They know that they name in the market as the founders of the RBI. They are not using the software. They have their own customized spreadsheets. They are managing to do that one.
I do like to lose this chance, but before concluding our session, let's take a look on in brief about an example of qualitative and quantitative damage mechanism in RBI.
So I will just like to quote here the two damage mechanism which is very common in all of the process industries there. One example is for the quantitative, one is for the qualitative approach there. COI. So COI basically very common damage mechanism in all of the insulated vessels in the industries there. So this when this damage mechanism occurred, so API launched one API which is 583, in which they specify the removal of insulations. You have to remove the insulation to detect this damage mechanism, and it is not only for the damage insulated areas or cladded. Addition to that, suspected also. Example, for example, I have a vertical vessel. So vertical vessel, there are certain areas where even with 100% perfection, there is a chance COE will occur there. What are those areas? The lifting lug areas, where this
in intersection with the
intersection of
somehow,
insulation, it is
proper
difficult.
sealing cannot be ensured.
So API know this bottleneck, so they mandate to that you have to open and inspect it. So whenever insulation opening is there, it is cost. So then here the RBI concept jump in. What they did, they embedded the 581, embedded the quantitative approach of the COE assessments. So it launched, there is certain inputs which you have to do for ferritic and austenitic steel. Ferritic steels, they are embedding it, based on my environment temperature. This is the corrosion rate. Based on that corrosion rate, what is the coating life? What is your inspection confidence, effectiveness? They will rank the equipments based on their probability level.
Number of coats as well.
Number of coats, and inspection confidence, inspection effectiveness, and in case of piping, the piping complexity factors, it will rank my equipments based on these all parameters. There is a calculations available. They're very each factor is reducing the probability to certain level. So by adopting this technique, we are able to rank our insulated vessel with certain probability level, and then based on that probability, API 583 also embed this in part. Based on different ranking, you can define your criteria, percentage removal of insulation to get the confidence.
That's for ferritic.
For ferritic. Coming to austenitic stainless steel, it is qualitative approach. So API 581 make a very simplified workflow there, in which they will is talking about if you have this material, this much temperature and this much, you have to remove this much ranking likelihood, and there is a damage factor adjustment based on the temperature. This will be activated there. So there it is limiting, also again ranking it one factor only, driving factor, which is based on the temperature rank. So they also rank it, but based on the qualitative approach, not the quantitative. So in the case of stainless steel, both damage mechanism are assessed in the RBI, and then ranking will be occurred. And this is now one of the fruit of the RBI, that after implementing this, I am able to comply to 583 requirement in the optimized way. I will not going to strip off the insulation for COE assessment if it is a low probability level there.
Can I think from this that and back to the initial part of our discussion in the session today, like even if all the information are available and the company adopted the quantitative approach for performing the RBI, it cannot be applied fully for everything. Still there is a limitation. There is a limitation because as I mentioned, we discussed it, there is some of the damage mechanisms, there are limitations there. Yeah. So same way we have STHA also, which I will like to quote here. If you go back, initially 581 make is a semi-quantitative approach, but with the passage of time, like back in from 2015 onward, it is a semi-quantitative assessment. But later now in new editions, they, with the different industry lessons, they have shifted to the qualitative approach. They make very simplified workflow. In the Nelson curve, whatever this more than 100 degree Fahrenheit, it will be no susceptible. From 50 to 100 medium, and from Nelson to 50, this is high medium, and above is highly susceptible. Then this basic concept only they introduced. But before that, there was a concept of some factor calculation of PV, which is link of partial pressure, temperature and exposure time, and then based on the material they tabulate it. This factor, if you calculate the value of this factor, this is the susceptibility. But with passage of time and the industry feedbacks, it was given there that this factor sometimes giving some people are really susceptible, but it was changed there, because if you know this Nelson curve is what it is, industrial experience is there. All the Nelson curve plotting is based on the industrial incidents there. Yes. So this Nelson curve also revising many based on industry experiences there. So they embed this approach in qualitative, and based on that, the qualitative approach, the assessment has been carried out, and it will be ranked. I think we have covered almost what we would like to discuss about, and really it was very informative thing and very fruitful discussion. Thank you so much, Mr. Saqib. and really we enjoyed this discussion.
I like RBI. It helps in ensuring the integrity of our equipment, and it makes like inspection a lot easier and more effective. Thank you, Mr. Saqib, for
Thank
being
you,
with us today.
Abu Umar and Mr. Bahar and Mr. Umar for your this session for this one. We use this platform and we discuss a lot of things, because as we mentioned that discuss it. Sometime RBI, it is little bit boring topic if you notice, mostly in
To
the
some extent,
to some
but
extent.
not with you.
So if we visualize the concept of behind that one, then it will make interesting there. It is our day-to-day activities. We are inspecting, you are inspecting equipment there, but what is behind that things? When you visualize, then you will feel the real weightage, or you will make it as interesting things there. So I wish that all of our industrial guys, especially the inspection team and our design team, they will have discussed this in detail, and they will understand the concept of this asset life cycle management concept. And it will be, as I mentioned, there is some side products also from the RBI which is beneficiary for other things. So it is nice discussion with all of you, and it was very good. So okay, thanks a lot.
Thank you. Thank you so
Thank
much
you
for
very
your
much.
time. Thank you. Assalamu alaikum.
Well, so.